0.818. Okay. So 6 multiplied by 0.866 is minus 5.196. Alpha minus by 179.156 times by 0.866 is equal to 155.149. And then it's equal to minus 3.732 alpha plus by 36.818. Okay, so let me do it again. 0.866 times 6. Yep, 179.156 times 0.866. Yep, plus 179 ABT. Yep, correct. So minus 3.73. Okay, so minus 5.196 plus by 3.732 is equal to minus 1.464. Okay, minus 1.464 alpha, and this will be equal to 155.149 plus by 36.818 is equal to 155.149 plus by 36.818 is equal to 191.967. Okay, so alpha will be equal to divide by 1.464 equal to 131 minus 131.125, okay, radians per second squared. And then your ABT will be equal to 6 multiplied by minus 131.125 plus by 179.156. Okay, so 6 times by minus 131.125 plus by 179.156. So this is equal to minus 607.594, okay, feet per second squared. Now, what does the minus sign means for both of them? Okay, so if we go back to our diagram over here, okay, the minus sign means what? Alpha by right has to be going where? Clockwise. So this is wrong. So if you change this, right? So alpha is equal to 131.125 radians per second squared going in a what? Clockwise direction. Yes or no? All right. And then your ABT, you assume it to go upwards, which is wrong. It should be going the way? This way. So this is your ABT, which makes sense because it will follow what? It will follow the orientation of alpha. So when that's the case, you write down that ABT is equal to 607.594 going downwards direction. We clear? Okay. So this question, okay, show a lot of components. I think most important of all, what I want to show is this part. Okay. In your homework, you have some questions like this. Okay. You need to know which formula to use. Okay. Be mindful. Okay. The ABN, the acceleration in the normal direction has to go through the what? Center of curvature of your path. Are we clear? Okay. And that's where you take your radius. Okay. So some of you might ask me, Eugene, is it possible to use this formula? Yes, it is possible, but you have to find a different omega. Okay. So I will do a bit more. So what if you want to use what? You want to find ABN is equal to omega squared R. You can use this, but you have to do this first. If you're going to use that, we know that the velocity is equal to what? 204.1. So V is equal to omega R. If you use 204 point what? Or 20.4. And this is between omega point B to O, and then multiplied by a radius of 2. So omega BO will be equal to 20.4 divided by 2. So it will be 10.2. Right? So if you want to use this ABN, you have to use 10.2, and now this is radians per second, squared, multiplied by the radius of 2, right? So you get 10.2 squared multiplied by 2, you get 208.08 feet per second squared. The answer will be the what? Will be the same. Okay, so you have to be really, really cautious. Do not use this. You have to know where the center of curvature is. I write down here, you need to know where the center of curvature. Okay, you need to know this very, very well. Okay. Right. So the next thing that I'm going to do now for the term test, we will do until here. Are we clear? Okay. The test on Monday will be until here. And you will go through homework what? Where's the latest homework I posted? 6. Okay. So you have to be able to do all these questions. Okay. All these questions, you must be capable of doing them. Okay. They're not that difficult at all. Right. So what I'm going to do now, a student asked me this question, and no doubt the solution is posted. It's still very confusing. So the question I'm going to attempt is this question over here. Have you all done this question? Yes or no? Hey, have you all reviewed this question? So this is homework 4. I'm not saying that this is my favorite question, but this question requires a bit of thinking. Okay. Do you mind if I attempt this question? Yes or no? Okay. Now, this question have a few core points that you need, or important points that you need to know. Okay. So regarding homework 5, we have to relate linear velocity with what? Angular velocity. That's the most important thing. Okay. So the slotted yoke is pinned at A. Okay. So we have a pin at A, while point B is used to move the ram horizontally. So the ram can be moved horizontally. I put the ram going in that direction because omega is rotating in an anti-clockwise direction. Okay. Sorry, clockwise direction. We have to determine the velocity and acceleration of the ram. The crank pin C is fixed to the disc and turned with it. Okay. So now, what are the variables? Okay. So what angles that is a function of time? So we can see down here, there are 2 angles going at a function of time. One is theta and the other one is what? Phi. Okay. So for the way we solve, okay, the rotation, the angle, only one can what? Vary. So we are going to pick theta, okay, as a function of time. Why theta? Yes. Wait. Yes. Say it again. Yeah. So theta as a function, why we use that? Because we know that d theta over dt is equal to what? Omega. We cannot use d pi over dt because we have not a clue what this is. You can work it out, but you don't have the time, 2.5 hours. Okay. Does that make sense to all of you? Yes or no? We are not given pi. Are we given pi at all? The answer is what? No. Right? So whatever we do later on when we differentiate or integrate, I can't remember now, it has to be a function of theta and not pi. Okay. So you need to get that this clear, because both of these, right? Both of these are variables. Okay, both of these, both theta and pi are a function of time. For this case, we only we would like to relate d theta over dt equal to omega, because omega is so-called a given what? Value. Unfortunately, d pi over dt, we don't know what it is. As I said, you can work it out with what you know now. Unfortunately, this topic over here is homework 4. So you have not learned VB equal to VA equal to what? Right? Omega cross RB over A. Are we clear? Okay. So from here, we start drawing the critical points. Okay. So we know, we are aware that this is our point O. Point O is the center over here. And directly below, we have a point A over here. Okay. And then at a certain angle, we have point C over here. So if I'm going to draw a straight line now, so what we are given that this angle is equal to pi. And what is also given to us is a very specific dimension over here, that the distance from here to here is equal to what? D. And then likewise, we are given the distance from here to here is R. Okay. And then at a particular vertical plane, we are given that this angle over here is equal to theta. Okay, that angle is equal to theta. And again, we are given that we have a length. Okay, so at a certain point over here, we are given a distance from here to here. And this is our L. This is our point of origin. And this is my X. X is where the ramp is. We want to find X dot, and we want to find X double dot. X dot velocity, X double dot is acceleration. So we can form the first equation, right? We can form the first equation. So the first equation we are going to form is X, or is equal to tangent pi is equal to X over, now this is a small L, I do apologize. Right? So X is equal to L tangent what? Pi. Now we cannot do this When I differentiate tangent pi, what do I get? Anyone? Can you remember? Hey? Secant squared L secant squared pi d pi over dt. Right? This is the most obvious step to take. Okay? But we can't do this because d theta over d pi over dt is unknown. Okay. What we only know is we know that d theta over dt is equal to omega. Right? So from here, we look back at sine x is equal to L tangent pi. Okay? So we know that this can be expressed as L sine pi over cosine pi. And when we come to this, this is good news, right? So now from here, we have to determine sine pi as sine pi and cosine pi as a function of what? Theta. Are we clear? Okay, because we only know what? D theta over what? dt. Okay. So from here, we know that this angle over here is 180 minus what? Theta. Okay. So we start applying sine rule. Okay. So the first thing we can do is sine pi over r is equal to sine 180 minus theta divided by AC. And this is